Good morning all. New printed circuit boards from JLCPCB. So let's take a look. In here, my printed circuit boards, and they're in fetching purple. Yes, purple is JLCPCB's new printed circuit board colour. I seem to remember they had it once before, a long time ago, and then it disappeared, and now it's reappeared. And so there they are. They're very simple. In fact, they're so simple that I didn't even draw a schematic for this. There are only two nets. There's ground on the bottom and there's, well, I called it plus 12 volts on the top, but I've since realized that actually it's 24 volts because this is going to take power from my lithium iron phosphate battery and distribute it, and hence the name XT90 distribution, to various places. As it stands, the battery will be on the left, the ant miner via relay and buck converter will be on the right, and the solar panel will come in on the top. Now I went to a trace width calculator. I'll put a link to that in the description below, to work out in 1 ounce copper. You can get 2 ounce copper from JLC PCB, but it's quite expensive. So I went for 1 ounce copper. How many amps I can put through this? I think I specified 12 amps, and it came up with a trace width of about 1 inch, I believe, 1 inch width. Now, of course, these are just copper areas. So there's one copper area for ground on the bottom, linked to the center holes on all 4 sides. And then there's a copper area on the top, which will be 25 volts, linked to the 2 outer holes on each of the 4 sides. So I think this should very easily, oh, and that I specified no more than 10 degrees Celsius temperature rise, and that's when it came up with 1 inch width. So this is effectively 2 inches square and quite short runs between the various connectors. I think this should take the 12 amps I'm expecting at the 25 volt side. It's more current on the when it's bucked down to 12 volts, of course. I think this should be no problem. So these are 3mm holes. They're quite wide pads so that I can put nuts. I don't think these are the nuts actually. No, I think they're 4mm. I'll get some 3mm nuts. I can stack nuts on top of this and then put my XT90s on. The pitch between the holes is 11mm. That apparently is the spec for the distance between the XT90 connectors. So let's get some XT90s and see how they marry up with this. So the XT90s are going to go across there. Now I provided an option to flip it over, really just because on some of these positive might be on one side, negative might be on the other. It might not be convenient to flip it over on my incoming wire, so I provided an option for it to be flipped over at this point. I measured this slightly different to 11mm, but I looked at lots of Google image searches and they're all saying 11mm. It's not that critical because if I'm using these rings, now I'm probably not going to place these flat on the board. I'm going to stack them up on top of one nut because I didn't cut away the ground planes. I mean, there is a small gap in there, but it's not fully cut away around that pad. So I'll probably stack nuts and then put these on. And these, of course, will be soldered directly into the XT90 solder cups. Now, I did think, possibly, and that's why I had 10 of these made, that if there was a problem with current carrying capacity, you could actually stack these with nuts between them for additional current carrying capability. Right, big box of nuts and bolts, and I'm pretty sure I've got 3mm in there. I think this came from Claes Olsen a few years ago, but let's get some 3mm nuts and bolts out. I think these are the 3mm. Not sure what length I want yet. There are various lengths, and there are nuts. Don't think I've got any washers. I don't actually know why. I'm sure it must have come with washers because all the other sizes have got washers. Maybe I used them all up on something. Right, let's see how good the fit is. Oh, that's a very good fit. Not tight or anything, but just absolutely the right size. So then the idea is to put a nut on here, screw it down, and then put my ring terminal. Now I've got a feeling these are actually 4mm, but it doesn't really matter. I mean, I can get some 3mm. Yeah, it's a bit of slop in there. But the important thing is to have it stood up off the board and going off to my XT90. Now in my original design, I mean, obviously this wants to be face up. Ground is on the underside, and what I call plus 12 volts, which is really should be plus 25 volts, is on the top. So let's get some nuts on there and some of these terminals. I think I've got two types of these. They're the same ring diameter, but I think the entry, oh yes, let's get a magnifying glass on that. Yeah, the entry size is different. I think the one on the left is probably a blue, but I think I bought these as no plastic coating on them. Can't remember what it's called now. The one on the right is almost certainly a red. Now I've got fairly fat cables. Oh no, I'm going straight to XT90, so cables don't come into it. Really, it's more about the outside diameter of this. Let's give that a try. Well, the big one, the blue, doesn't quite sit in the cup, although it probably would if I crushed it a little bit. Or shall I go for the red, which is actually quite a loose fit in there, but once there's solder in there, then yeah, I think I'll probably go for the red ones. I mean, that should be more than enough current handling. Yes, I think I've got the pad size about right. The hole size is perfect. The pad size takes the nut with no spillover. I've got a fairly large, I think it's 0.5 mm. What's this called? The spacing between the copper area and a pad which doesn't connect to that copper area. The other thing is that these pads are not spoked out onto the copper area. They're directly connected all around. The only reason to use spokes really is if you're soldering, because then you don't get quite so much heat being sucked away into the copper area. Here, because I'm using bolts, heat loss is irrelevant. So yes, I put a direct connection for the extra current handling. Tighten these nuts onto the bolts and then put my ring terminals on. So I think the way I'm going to solder these is to just push that on so that it's a slight interference fit, so that's holding itself on there, and then just apply solder onto there, solder onto there. Now it's all going to get sucked back through these bolts, so I really need a very hot soldering iron. Now I don't need to think at this stage whether I want pos to the left or pos to the right, because these pins rotate in the XT90 housings, so that if I've got this wrong, I can always take it off, put it on the other two bolt studs, or if I need to flip it over. I really do want the ring terminals coming down. I can simply rotate these two so that it's in the right orientation. The other thing, of course, is whether I want male or female on the three sides. I'll probably go out to the shed actually and just do a sketch so that I kind of know what I'm doing, but I want to try a solder joint first. So I've been out to the shed and just done a sketch of what I need. That's male, isn't it, at the top there? But I got pos and neg the wrong way around, so I'll flip that over, put the other two on. But now the other thing which I went and got is my old Weller soldering iron, because this one, I don't know whether you can see that just there, let me get the magnifying glass. It's 60 watt, 240 volts. So now I kind of don't like mains irons anymore, but of course there's not really a problem because I can use one of those portable power stations. I actually put one of those on because when I was using this as a field service engineer, there was always a handy IEC plugged into the wall, so I put an IEC on the end of my soldering iron. Yeah, I'll plug it into one of the mains power packs, but this is 60 watts, so it's got lots of power to replace lost heat. So I haven't used this for years, but let's give it a go. Right, let's turn on the power bank. It's AC on. What does it say? Oh yeah, it's drawing 62 watts, so that looks about right. So let's wait for that to get hot. Oh yeah, that's getting quite warm quite quickly. Is that going to melt solder? Well, I'll let that warm up and I'll be back. This is taking an age to warm up, but I seem to remember these old mains irons did. They took forever to warm up. That's now warm, but I think I'll just leave it for a bit longer to get really hot. Still pulling 60 watts from the power bank, so that seems fine. Okay, that side's taken, that's fine. I'll flip it over and try the other side. I think this is hot now. I'm not sure I can see very well what's going on. I'm not sure if you'll be able to see very well either, but let's feed some solder into there. Oh, it feels hot now. Oh yeah, that's starting to take quite quickly now. But can I get the connector of the XT90 warm? Oh yeah, there it goes. It's suddenly started to flow. And that's done. So lots more of that. You don't need to watch that. I'll come back when it's done. Right, the soldering is done. Let's have a little look at that. Yes, I think that looks all right. A direct connection between the ring terminal and the XT90. So now it's just a case of putting the bolts through onto my board. So I'm working with my diagram to get males and females in the right sequence, and using this little spanner and a screwdriver to tighten these up, keep them nice and tight, and then I'll place these on and we can go and test it. And there's the finished thing. Male there, because this is the sort of connector, the female, that you see on a source of power or voltage. So the solar panel comes in there. The battery, of course, also has that kind of connector, so it fits into this male. And then this is the supply that goes off to my load, and hence that's on a female, or that star connector. So that should be a drop-in connector block for my setup as it currently is in the shed. Shall we take it out and shove some current through it? Now, could I simply drop another PCB on top of there? My bolts are a little bit short, but yes, I could. Actually, would a nut tighten up? But I'm not sure I need to, because I think, yes, that just tightens up on there. I think it's going to be fine with just the one PCB, but this is an option if I find it's getting a bit warm. Don't think it will, but it's an option nonetheless. Right, I'm out in the shed. It's extremely cold. Actually, what temperature is it? 6.5 degrees. So I've been using this. This is a balancer, but it balances extremely slowly. It has balanced the cells up a little bit. Of course, it balances by pulling the high voltage cells down using little resistors in there. So it will have lost, because I had it running all night, so it will have lost a little bit of charge from the batteries. But anyway, I want to remove this, which is my current connection from solar. Now I've got this bulb in series with the solar to limit the current, because I'm not watching it all day. So if suddenly 8 amps comes from the solar, it's going to take the batteries over the top. But I don't think that's happened yet. So I can take these off. Oh no, mustn't short those. Must not short those. Should do this in a more logical sequence really, but there we are. I'm all excited about my new XT90 distribution. So I can plug this in, because that's just connecting solar to battery. Oh yes. There is of course the thought that there might be a short. There shouldn't be. So yeah, that's the right way around. Let's plug that in. Yeah, I really should start using silicone wires rather than these rather stiff wires that I've been using. Oh, that's a bit of a tight fit actually. Will that go in? Yes, it will. It's just the angle. Okay, that all looks good. That's solar connected to battery, so these voltages should be going up now. Oh yeah, I've got a 3.5. Yeah, that one's nearly topped out. Cell 8. Oh, can you see that? Not very well, but you can see the bar on cell 8 is way ahead of the others. So there should be enough energy in here to do a mine. Right, here's my buck converter to take the 24 volts down to 12. I've got pos on the bottom. Yeah, pos on the bottom. That's good. And now I'll bring in the... Oh, look what I've done. I've put pos on the bottom of that, but I've got pos on the top of that. Oh, that's silly. And you haven't seen this yet. It looks really good, actually. This is my new voltage trigger with a 30 amp relay. So I'm just going to have to go and get that spanner. Ooh, really shouldn't be undoing these nuts with this powered up. So I'll take this out. I could take the fuse out of the battery, but I'll just disconnect that. Go and get my spanner, flip this one over, hook up my discharge control relay, and I think we're ready for a mine. Right, I've got the spanner. Now I probably shouldn't spanner this with the solar panel connected, but I can quite easily just remove that bulb to break that connection. Right, this I can now spanner without fear of shorting across the plus and minus. Flip this over so pos is at the top. Let's do that. Yes, I think I'm going to have to rotate the... Oh no. Yeah, pos at the top. I want to rotate these, don't I? So I'll go and get a pair of pliers. These are my shed pliers. So rotate those around so that it fits on that way. Pos to the top. Oh, I need to move the bolt to the top, don't I? Yes, I do. Right, I think this is correct now. So I'll put my relay unit on there. I could actually plug the solar panel in and see if it powers the relay unit up, just as a sort of initial test. It may or may not. Oh, it does, because it's overcast outside. Yeah, that's interesting. And the panel's at 33. Oh, within 1/10 of a volt of my other meter. Now I've got to attach the battery. Well, I suppose this is a good way to do it. I was a bit nervous about the buck regulator on the other module of this because it's now fried. So now if I attach the battery, that should drop to the battery voltage. Now, positive, most definitely there. Neg is this center hole and pos is the outer holes. Yes, that looks fine. Let's connect it up. That looks good. That's dropped to 27 volts. Oh, I think that's the point at which the relay comes on. Yes, it is. Now I've got to try and remember the operating system. Don't want to spoil the video that I'm going to make about this, so I'll just sort that out. Right, 27.2. I've set this for 27.5. It should creep up with that bulb in the solar panel line. Let's connect the buck converter onto there, and that goes off to the ant miner. So when this gets up to 27.5, just see what the voltages look like on there. Yeah, the highest voltage is 3.4, so it's not anything to be concerned about. When this gets up to 27.5, which it should do, there's only half an amp flowing through that bulb at the moment. This should turn on and it should start mining. But this, I'm very happy with that. It's very neat. It's absolutely rigid because all these wires are stiff wires that ain't going to move anywhere. Yeah, I like that. And then of course it's the case of seeing whether it gets warm. Right, waiting for that to get to 27.5. I'll come back when it does. Yeah, this highest voltage cell 8, can you see that? It's very difficult to film these things. Is starting to accelerate away now. 3.567, 27.3 on there. So just waiting for, well, they're all coming up, but this one is going to come up the quickest. And waiting for that to give a 27.5 on here. and then it should all burst into life. I'll try and capture the moment when the relay comes on. There's a little red LED in there, so we should be able to see it. I'll just leave the camera running. Yeah, it's on battery, that's fine. Oh, 3.6 on cell 8. Now, of course, the danger is, well, actually, the BMS doesn't turn off until this gets to 3.75. So I don't think we're going to get there before this gets to 27.5. It's on 27.4 at the moment. I'm not sure if you can see that very well, but I don't think we're far away from this relay pulling in. Cell 8 has suddenly started climbing. 3.64. Yeah, with that having a bit of an acceleration forwards, that could push this over. It's a bit silly really. I should have set this to slightly lower threshold, but I haven't. Oh, 3.66 there now. That's really starting to shoot up. This is so annoying, this thing won't stay on. Oh, relay click. Can you see the red light? Can now. I'll move the camera slightly to the right. But anyway, the miner has come on. Now the voltage should 27.3. That's because only the fan and the control board on the miner are on. But when that spins up, which it's going to do any minute now, this voltage should fall, but obviously not to the lower threshold. That's 22.5, I think. Maybe you can see this. Oh, that's starting to fall quickly now. I think the hashing... Oh no, they don't start yet. Don't know, 26.0. Right, the fan has gone up and come down, so now there should be about, I don't know because I haven't measured it, but I think about 12 amps going through this, and that's absolutely stone cold. So I don't think there's a problem. I don't think there's going to be a problem. I don't think I'm going to need that second board, but it's always an option. No, that's absolutely fine. Let's have a mining session. I won't show the whole of that because that's a bit tedious. But what I really wanted was to have the load switchable in, pulling from the battery, but also have the solar panel connected at the same time, because anything coming in from solar will just slightly lengthen the time that the miner mines, and that's always a good thing. And if the sun came out strongly, which it's not going to today, I don't think, that could elongate the mining period, well, almost continuously. I just need to work out how to resolve the problem, and I think it's going to be another one of these voltage relays in here, and I can actually connect it into this fuse holder. What happens if the sun is so strong that it is providing more current than the miner is actually taking? Then the battery will continue to rise up, and that's why I think I need another relay unit here. So if the battery gets anywhere close to the BMS turning off, where a cell gets to 3.75, and of course the problem I've got at the moment is that the cells are so imbalanced. I mean, they're all balanced now because they're being heavily pulled down against their springs. They're so out of balance that none of these voltage measurements is very good, because the cells are so imbalanced. So I'm waiting for the 8-cell balancer, and then yes, if the solar is so strong that it's lifting the batteries up even while it's mining, there'll be a second relay which will just simply turn off the solar panel, but only briefly. I don't want it turned off for the entire... I can't, use the normally open contact on here or whatever to disconnect the solar panel, because I don't want it turned off for the entire duration of the mining. I want it to supplement the mining process. And if you're wondering what happened to the ideal diode, well, it's here, but I don't really need it because the nighttime backfeed is only 20 milliamps. So it was interesting to test it, but yeah, it's out of circuit. Oh, and if you're wondering what happened to the bolt stack abomination, well, it's here, but yeah, I didn't like it either. So this is all going perfectly well, 24.2 volts here now. The lowest cell is 3.01, so we might be getting close to the sort of ramp down phase. But I have been thinking about these. This board, of course, has two potentials on it. It's double-sided, so ground on the bottom, 25 volts on the top. But what say you if I came up with the crazy idea of not having these big, thick copper bus bars on my battery pack, but instead I use printed circuit boards? Yes, I know what you're thinking, but you've got to remember that there's only one potential on a bus bar, so you can use both sides of the copper, so you'd actually have twice the current handling capability. And the other thing is you could do really clever things like, I mean, you could have little sticky out bits with a bolt stud for attaching your balance leads, this sort of thing. But you could also put little ACS 712 current sensors on the board, surface mounted, and put the balance currents through those current sensors, and then have a little 3-pin connector going off to an Arduino, so that you could have these, not this shape, but probably be 1 inch by 2 inches perhaps, sitting on there as a bus bar, but that can also do fancy stuff like current measurement. That's an idea that I've been thinking of. Yeah, this is all working nicely. 2.99 on the lowest cell now. Oh, and I suppose the thing you really wanted to know is this warm at all? No, it's absolutely stone cold on both sides. Yeah, that's sucking heat out of my fingers. That's cold. Now I've just gone in to get the other battery checker, because this one I think is a bit more visible. So let's pull this one off and shove this one on. Oops. Can you see those numbers? Yes, I think you probably can. 2.92 is the lowest cell. They are much better balanced now, because this thing, which is a balancer, it's a very low current balancer, but it has been on the battery pack I think for 2 nights running and a day in between probably, so yes, they are better balanced. But what this system really needs now urgently is the 8-cell balancer for the battery pack. Just a roving shot because you don't get to see the whole system with the camera mounted. So battery pack, BMS, fuse there, cell monitoring device there, my new XT90 distribution there, solar panel comes in here with a bulb in line with it, just to limit the current for the moment. That's not going to be there permanently. Voltage switching relay, buck converter, some horrible old connector thing to translate into these PCIe cables, and ant miner, and that battery pack there is just powering this camera. Right, we're heading down to the end of the mining session. 2.33 on the lowest cell. Now there's a race here because these cells are so out of balance, it's possible the BMS will actually turn off at 2.18 before this turns off at 22.5. So just keep an eye on that. 2.26 there, 22.9. If this gets down to 2.18, then the BMS will cut off and this display will go blank or disappear. Yes, it's definitely a race. 0.3 of a volt to go on here, but precious little on cell 2, and it's because it's out of balance. I mean, the highest cell is 3.07, 2.19, that's about to go, so I think the BMS is going to cut. Ah, that's interesting. Did the BMS cut out and then immediately cut back in because this is actually powered up? Yeah, that's interesting. I don't know why that's flashing. That'll be explained in the video about this unit if I can fathom it out. But anyway, I think that's it. Really, it was about my XT90 distribution board, which has been an absolute success because that's stone cold, handles the 12 amps no problem. Happy with that. Cheerio.